In the chemical equilibrium lab, you're going to mix iron and thiocyanate in order to form the iron thiocyanate ion. So very similar to what you did in the Le Chatelier's principle lab, but this time you're going to determine what the equilibrium constant of this reaction is. So it walks you through in your lab handout some equations that can help you figure out some of the things you're going to need to know later. But we're going to talk more in depth here about what exactly you're going to do in this lab. So your lab handout walks you through the data collection. Let's talk about processing the data. So step 1 tells you to write the Kc expression for the reaction. I'm going to allow you to do that because at this point you know how to write Kc expression. So you're going to write your Kc expression for the iron thiocyanate reaction. Now step 2 says to calculate the initial concentration of iron 3 positive. So what you do is you take your original 0.0020 molar iron nitrate solution, and for each one, you're going to dilute that. So if you think back to your dilutions, M1V1 equals M2V2. So if we go to our concentrations, we have our original molarity as 0.0020 molar. And if you look at the table under the procedure, in each test tube, you will see that there is a total of 10 milliliters of solution. In each one of those test tubes, you are going to add 5 milliliters of iron nitrate, and you're going to dilute this to 10 milliliters using a certain volume of potassium thiocyanate and a certain volume of water. So, if we divide both sides by 10 milliliters, and you can put this into your calculator. So we're going to take 0.0020 times 5, divide that by 10, and we get 0.001 molar for the iron. So this is going to be the concentration for the iron 3 plus for all of your solutions. Now in step 3, you have to calculate the initial concentration of SCN negative. So again, this was for iron. So for SCN negative, we're again going to take our M1V1 equals M2V2. Now your lab handout shows you a slightly rearranged version of this equation that you can also use to do the calculations. But this is going back to how we've been doing it since Chem 111. So we start with 0.0020 molar potassium thiocyanate. And we're going to look at test tube 1 here. So your concentration of potassium thiocyanate will not be the same for all 4 of your test tubes. In the first test tube, you're going to add 2 milliliters of potassium thiocyanate. And you're going to dilute that to a volume of 10 milliliters. So if you divide both sides by 10 milliliters, we're going to take 0.0020 times 2, divide that by 10, and we get 4 times 10 to the negative 4th molar for test tube 1. Now, I'm going to let you calculate the concentration of thiocyanate, SCN, not SN negative. For test tubes 2, 3, and 4, you're going to follow the same procedure. So then what you're going to do is you're going to calculate the concentration of your iron thiocyanate. And the way that you're going to do that, 2 positive, is you're going to take the absorbance at equilibrium, divide it by the absorbance of the standard solution, and then you're going to multiply that times the concentration of the standard solution. So AEQ is your absorbance at equilibrium. And A standard is your absorbance of your standard solution. FeSCN2 positive standard is your concentration of the standard solution. So if we think back, for each one of these, we are taking our iron and we are diluting it with the potassium thiocyanate. So if you go through and do the calculations, FeSCN2 positive comes out to be 0.0020 molar. So you're going to do that calculation, and then let me add another slide in here. Actually, let's go ahead and add a couple more just in case. As step 5, you are going to calculate Fe3 positive at equilibrium. And the way you're going to do that is you're going to take your initial concentration of iron minus the concentration of SCN2 positive that formed at equilibrium. And you know what your Fe3 positive concentration was because we calculated that back a couple of steps ago. So we said our iron 3 positive initial concentration is 0.001 molar. And then you're going to subtract the FeSCN2 positive concentration that you came up with. Then in step 6, you need to calculate SCN negative. I keep switching the C and N here. SCN negative. And you're going to do that by taking SCN negative initial minus FeSCN2 positive at equilibrium. So you are going to plug in here the concentrations that you calculated back in step 3, because remember, your SCN concentration is not going to be the same for each of your calculations. Then in step 7, you need to calculate Kc. So you will have to determine your Kc expression and then substitute in the correct values. And then in step 8, you're going to calculate an average Kc. So you're going to add up all 4 of your Kc values and divide by 4, and that will give you an average Kc. So This is your chemical equilibrium lab. So make sure that you have submitted your purpose and procedure on Canvas, and I will see you in lab.